What this is important about this material is not the element. What is important about this material is the resonance frequencies that come off of it. And that's what you're after. What's important to you is the resonance frequency. All of these elements are basically transition elements, and this is a periodic table, but this periodic table I found actually has the electron configurations. And it's really important to understand, particularly for gold here. You know, gold is element 79. It's a 5d10, which means its electron orbital, the 5d orbital is totally filled, but it's a 6s1. 6s1. Over here is the elements that, in this row right here, that normally we find has all S1s. Hydrogen, lithium, sodium, potassium, cesium, rubidium, strontium. These are the elements that have S1 orbital configurations. They're highly reactive elements. Gold, we all think, is noble. It doesn't react. But when you understand that gold is an S1, it cannot exist as an S1. And yet gold metal is supposed to be an S1. But it can't exist in a single atom as S1. It wants to be S2, or it wants to be S0, but it doesn't want to be S1. If it's S1, it wants to react with something, and it will find a partner. Even if it has to steal it from somebody near him, it will find a partner. Now, when it finds itself, when gold finds another gold atom, it locks onto it and says, now I have the orbital has 2. So now I have ORUS, gold 1, plus ORIDE, gold minus 1, and we now are a diatom that we call gold 0, or gold metal. But gold metal is ORUS, ORIDE. It's not really ORUM. Okay? There's no such thing as ORUM. Gold metal is ORUS, ORIDE. It's not ORUM. Okay? Everything is fine. 2 atoms, 3 atoms, 5 atoms, 50 atoms, 1,000 atoms, doesn't make a difference. It's all ORUM. It reduces to gold 3, gold 1, gold 0. But when you have one atom, it doesn't work this way. One atom, this naked little single atom, it's gold 3, gold 1, and then gold minus 1. Because it can't be gold 0. It has to have an extra electron, or it has not have that extra electron. So it gives it up. So it can't be gold 0. A single atom cannot be gold 0. So in the published literature, there actually are people who have written papers about how you produce gold ORIDE. Gold minus 1. What you do is what Barry Cotter calls a sodium burn. You take metallic sodium, you pull it up out of the oil where they keep it so it won't oxidize. You cut part of the sodium off, you put it in a zirconium or you put it in porcelain crucible, and you heat it till it melts. Then with the molten sodium, you put metallic gold in there, and it literally dissolves and goes into the melt. Now, the gold-gold bonds become sodium-gold bonds in the melt. Then the sodium gold can be taken out and hydrolyzed with water, and it becomes the hydroxide. Now you can acidify it, and you now have sodium gold chloride. If you strongly acidify it, you become hydrogen gold chloride. If you reduce it, it becomes gold 3, gold 1, gold minus 1.
Does it look different?
Well, you know that the single atom of gold is green as a chloride. Now that is conspicuously different than all the metallurgists in all the world think that gold chloride is kind of an orangey red color. Monatomic gold is forest green. And you reduce it, it becomes clear as an ORIDE. Now an ORIDE is just like bromide, iodide, chloride. It's a halogen. It's ORIDE. It's a halogen. Can you imagine melting a halogen in your furnace? You're going to put chlorine in here and melt it to a glob and make jewelry out of it? Ain't going to happen. As soon as you start warming it, it's gone. You try to put monatomic gold in there and heat it in the furnace, and it goes right out the furnace. It's not there. And people in the electronics industry are following this very closely now, and they're aware of this, that gold, because electronic configuration, cannot be gold zero unless it has gold-gold bonds. And when it's a monatomic material, it doesn't want to form a bond once you reduce it. Once you anneal it and it goes white, it will not react with anything at all. The white powder of pure gold will not dissolve in aqua regia, which dissolves metallic gold, but it won't dissolve the white powder gold. It won't dissolve in nitric, sulfuric, perchloric, any acids. It won't dissolve in bases. It won't dissolve in caustic. It will dissolve, however, in a sodium fusion. So if you want to take monatomic white powder gold back to yellow gold, it has to go through a sodium fusion, acidification, then a reaggregation, a precipitation of the sulfide, drying of the sulfide, and then reduction of the sulfide to the metal. But it can't just, it has to be physically brought together, glued together, and then reduced to the metal. React with nitrogen you breathe, comes in and forms a resonance coupling with the white powder. It just resonates. Pretty soon the white powder starts pulling back and starts developing a feeling there's going to be a bond, and then electron annihilation occurs. When that annihilation occurs, it's received by the smaller atom, which is the nitrogen. And nitrogen, which you're breathing, every breath of air has more nitrogen than you have oxygen, and the nitrogen becomes radioactive carbon-14 while you're breathing. Annihilate to produce gamma level radiation at exactly the frequency that's required to create transmutation of a proton to a neutron. Okay, and this can happen. It can happen naturally too. Every now and then radiation just hits it and it transmutes back. In our bodies, these elements in the Orm state, when you receive radiation damage, it's possible that the Orm state can react with nitrogen you breathe, comes in and forms a resonance coupling with the white powder. It just resonates. Pretty soon the white powder starts pulling back and starts developing a feeling there's going to be a bond, and then electron annihilation occurs. When that annihilation occurs, it's received by the smaller atom, which is the nitrogen. And nitrogen, which you're breathing, every breath of air has more nitrogen than you have oxygen, and the nitrogen becomes radioactive carbon-14 while you're breathing. Now we finally waded through all this science because some of you people want to see, references and supporting evidence and all. That's what I gave you. Here's the supporting evidence. Okay. I was approached by a gentleman's representative who is so wealthy that I didn't even know anyone with that kind of money existed. I mean, makes Gates look like a pauper. I mean, this is heavy duty money, and I haven't even heard of the guy. Anyway, he's on the other side of the world, and they handed me, $300,000, said pay all your obligations, pay your EPA, get rid of them. We want to work with you over in the other part of the world. He says, we will give you all the money you need to do the work. We'll build another plant over here in the other part of the world, all brand new. We'll put it into operation, and you make the ore, you pulverize it, ship it overseas to us, and then we'll do the refining and processing over here. Their specialization, the people we were working with were all medical people, okay? And their goal, their object was to create a cure for HIV in Africa at no charge. Now, this is really a philanthropic gentleman that really was the head of the whole thing. And very seldom do you find this kind of money controlled by one single man. Over here, it's always big, huge corporations or something, but this was one man that directed everything. And, I decided, this is going to be really interesting to do. I got to have dinner with him whenever I was over there. I sat at a big round, 30-foot round table with the heads of state from China, the heads of state from Thailand, and the heads of state from Japan, the heads of state from Korea. We're all there at his round table as I was eating dinner with him, and my interpreters were there. Anyway,